Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know about parabolas. So parabolas are just the graph of quadratic functions, y equals ax squared plus bx plus c. When you're graphing a parabola, look for these four features. So I'll demonstrate this through an example. Y equals 2x squared minus 7x plus 3. This is a quadratic equation. Its graph will be a parabola. So first step is find the y-intercept. To do that, let x equals 0. Well, if x equals 0, you get 0, 0, 3. This constant is the y-intercept, so the graph will pass through here. That's really easy. The next part requires a bit more work. To find the x-intercepts, you let y equal 0. So what I'm going to do is take my equation here, and I am going to replace y with 0. So this will require us to either factorize or use the quadratic formula. Either way is fine. So to factorize, because this is a non-monic quadratic, AC is 6. The two numbers that multiply to 6 and add to -7 are -6 and -1. All right, so now I'm going to factorize the first two terms, highest common factor being 2x, and then I'm going to factorize the next two terms. So I end up getting 2x minus 1, x minus 3. So the solutions here are x equals a half and x equals +3. You would have got the same answers from the quadratic formula. These two solutions are the x-intercepts. So one x-intercept is here at 3, the other one at half. You can just estimate it's about there. So the last thing I need to do is look at the axis of symmetry. X equals minus b over 2a. So x equals minus b over 2 times a. You get positive 1.75. Now you need to substitute that into the original equation to find the y value. So doing that, I get minus 3.125. So the turning point, or axis of symmetry, is x is 1.75. It's about there. So the axis of symmetry always goes through the turning point. The y value of minus 3.125 is just below -3, so it's about there. Now, the orientation of the parabola, you can probably guess which way it is from this, but if a is greater than 0, it's a smiley face. A is less than 0, a frowny face. Here, a is 2, it's positive, it's a smiley face. We're just going to join up all these points. So the parabola stops and turns at its turning point. That is it. That is the graph done. Let's look now at the rate of change. So we're going to calculate the average rate of change of the quadratic function, the parabola we just graphed, between x equals 1 and x equals 5. So this is a rough sketch of the parabola we just graphed. So we want to calculate the average rate of change between here, where x equals 1, and here, where x equals 5. All we're doing is drawing a secant, a line between those 2 points, between these two x values, and calculating the gradient. That's all there is to it. So if x equals 5, the value of the function is simply 2 times 5 squared minus 7 times 5 plus 3. It is equal to 18. When x equals 1, the value of the function is just 2 times 1 squared minus 7 times 1 plus 3, which equals -2. So I just got this value by substituting x equals 5 into this equation, this value by substituting x equals 1. So now I'm just going to find the gradients between these 2 points. It's nice and easy. It is just y2 minus y1 over x2 minus x1. So we can use our calculator if we like for this. It's just 20 over 4, which is 5. That's the average rate of change. On average, each time we went across 1, we went up 5. In total, we went across 4 and up 20. All right, let's now look at the intersection of a line and a parabola. So suppose we have this parabola drawn in red. There are three options for any line. The line can intersect the parabola twice, in which case we call it a secant. The line can intersect the parabola at just one point, in which case we say the line is a tangent, or like this yellow line, it might miss the parabola altogether. So how we calculate these intersection points, we simply equate the line and the parabola, because they must have the same x and y values at the point at which they intersect. So this question is telling us calculate the value of k if this line is a tangent to this parabola. So if the line is a tangent to the parabola, it means they intersect once and only once. The way you calculate the point of intersection is you equate the line, which is kx, with the parabola, x squared plus x plus 4. Now, the points of intersection between line and parabola are precisely the solutions to this equation. So if there is only one point of intersection, this equation has only one solution. Now, remember when you're solving quadratics, whether you're using factorizing or quadratic formula, one side must be equal to 0. So I'm going to subtract kx from both sides of this equation in order that one side is equal to 0. So the two terms that have an x, I can factorize. I can take out x and I'm left with 1 minus k. So 1 minus k here is the coefficient of x, it's my b value. See, if this equation has one and only one solution, that means the discriminant is equal to 0. The discriminant is b squared minus 4ac. That has to be 0 if there is to be one and only one solution. So I get 1 minus k squared minus 16 equals 0. So I'm going to use difference of two squares. Perfect square minus a perfect square. You set up two brackets. Square root the first. Square root the second. One gets a plus, one gets a minus. So just simplifying each bracket, the first bracket is 5 minus k, and the second bracket is minus 3 minus k. So null factor law says if something times something equals 0, either the first something is equal to 0, that gives us k is equal to 5, or the second bracket is equal to 0. And that gives us k is negative 3. So if k is either of these two values, then the line will have only one point of intersection with this parabola. Y equals 5x only hits this parabola once. Y equals negative 3x only hits this parabola once. All right, let's now look at a max-min problem. So we know how to find the turning point of a parabola at x equals minus b over 2a. The turning point of a parabola is either the maximum or minimum value of that quadratic function. If it's a smiley face, this is the minimum y value of the parabola. If it's a frowny face, the turning point gives us the maximum y value of the parabola. So we can use that in problems like this. So the price of an item is given by 300 minus 2x, where x is the quantity sold. Calculate the maximum possible revenue. So the revenue is just the price times the quantity sold. So in this case, the revenue is equal to price, which we were told was 300 minus 2x, multiplied by quantity sold, we were told was x. So expanding this, we get 300x minus 2x squared. So what would be the maximum revenue? Well, we know that if I were to graph this parabola, it would be a frowny face, because this value, the a value, the coefficient of x squared, is negative. So that means that this function will have a unique maximum value. So how do we find such a maximum value? It always occurs at x equals minus b over 2a. Now when we're talking a's and b's, remember a is the coefficient of x squared, b is the coefficient of x. So here it will be x equals minus b over 2 times a. That gives us 75. That's not our final answer. X is not the revenue, X is the quantity sold. We've just found that the revenue will be maximized if we sell 75 items. So what will be the maximum revenue? Well, we simply substitute it back up here. So the max revenue will be 300 minus 2 times 75 multiplied by X, which is 75. And you can use your calculator for that. You get 11,250. That is the maximum. All right, thank you so much for tuning into this video. Best of luck studying, but don't worry, you will ace it. You're a star. This has been the luckiest maths teacher in the world. Have a great day.